Science Explorers! I'm Hypothesis Hallie, and this is Awesome Air. For our experiments, you're going to need the Awesome Air kit. You're also going to need a ruler and some scissors. Pause the video to gather whatever you need, and then we'll get started. Take a deep breath in, then let it out. When you breathe, you fill your lungs with air. Even though air is invisible, it still takes up space and has weight. Let's think about a balloon. Before you fill up a balloon, it's flat. But when you fill the balloon with air, the air takes up space and pushes out on the balloon to inflate it. Air also has weight. Air pressure is the name for the weight of the air molecules that are pressing on our bodies all the time. Daniel Bernoulli was a Swiss mathematician who did lots of experiments with air. His experiments showed that the faster air moves over a surface, the less it presses on the surface. Bernoulli's principle states that faster moving air has low pressure, and slow-moving air has high pressure. We're going to do some experiments today to see how this works. For our first experiment, you need a piece of paper, a paper clip, a ruler, and some scissors. Pause the video to get your things together, and then we'll get started. The first thing we need to do is cut off a strip of paper. We're going to cut a strip that's about 1.5 inches wide off the short side of our paper. You can set this aside for now. Take our square piece of paper and fold it in half. Place this tent on the table. What we're going to do is blow through the opening of our tent. What do you think is going to happen when we blow air through the tent? Make a hypothesis, and then let's try it. Did you see what happened? Let's try again. We know Bernoulli's principle says fast-moving air has low pressure, and slow-moving air has high pressure. When we blow through our tent, we are creating fast-moving air, faster than the rest of the air around the tent. That means our fast-moving air has low pressure. There's an area of low pressure inside the tent. Areas of high pressure want to move into areas of low pressure. So the air around the tent presses in towards that area of low pressure and the tent flattens. Pretty neat. Let's do another experiment with our paper. Hold the strip of paper just below your bottom lip and blow over the paper. What do you think will happen? Make a hypothesis, and then we'll try it. Ready? It's Bernoulli's principle again. When we create fast-moving air over the paper, that creates an area of low pressure. That means there's high pressure underneath the paper. Air pressure presses in every direction, even up. When there's low pressure above the paper, the high pressure underneath lifts the paper. Let's see what happens if we put a paper clip on the end of our strip of paper. Do you think we'll be able to use Bernoulli's principle to lift the paper clip? Make a hypothesis, and then let's test it. Let's find out. Air pressure is pretty strong. Even when we put a weight on our strip of paper, the air pressure is still strong enough to lift it. For this experiment, we're going to use the two 5-ounce cups and the styrofoam ball. Pause the video if you need anything, and come back when you're ready. I've got a challenge for you. Can you get the styrofoam ball out of this cup without using your hands to touch the ball or the cup? Give it a try. See if you can figure it out. Then I'll show you how it's done. Here's what we're going to do. Blow straight down into the cup with the ball. When we blow downward, it creates an area of low pressure above the ball. The air around and underneath the ball still has high pressure. Air always moves from an area of high pressure to low pressure. So the air under the ball is rising into that area of low pressure, and the flow of that air moves the styrofoam ball. Here's a real challenge. Do you think you can move the ball from one cup to the other just using air pressure? Have fun trying it out, then come back for another experiment. For this experiment, you need the wind sock out of your kit. Pause the video until you're ready to get started. First thing we need to do is shake out the wind sock. One end is closed and one end has an opening. Open it up and give it a little shake. Here's my question. How many breaths do you think it will take to fill the whole wind sock? Make your hypothesis, how many breaths, and then try it out and see if you're right. Well, how many breaths did it take? A lot, I bet. I'm going to show you a quicker way to inflate the wind sock. Hold the opening of the wind sock 6 to 8 inches away from your face. Then blow into the wind sock from this distance. Do you see how quickly we can inflate it? What we're doing is using Bernoulli's principle. By blowing from a distance, I'm creating that area of low pressure with the fast-moving air, and allowing the air with high pressure to rush in and fill the low pressure, moving more air into the wind sock. It also helps to push the air down to the wind sock so it can get all the way to the end. For this activity, we need a straw, a pipe cleaner, and a ping pong ball. Pause the video and come back when you're ready to get started. We need to make a loop on the end of our pipe cleaner about 1.5 inches wide, just a little bit smaller than the ping pong ball. Something like that. Now about 3/4 inch below the loop, we're going to start wrapping the pipe cleaner around the straw. Something like that. Bend the straw so it's at a 90-degree angle. The short part of the straw should be pointing up, and the long part is going to point out. Then we want to center the loop over the short end of the straw. Like a basketball hoop. Place the ping pong ball on the loop and then blow into the long side of the straw. What do you think will happen? Make a hypothesis and then we'll find out. Ready? This is another example of Bernoulli's principle. When we blow into the straw, the fast-moving air under the ping pong ball creates an area of low pressure. The high-pressured air around the ping pong ball rushes in and lifts the ping pong ball. The high-pressure air also presses in from all of the other directions and holds the ping pong ball in place. See if you can catch the ping pong ball back on the loop.